I hated the video because I have to follow it up. So I want to talk about connected vehicles, change things up a little bit from the consumer side of the program to some of where we're going with the government, with US DOT, and some of the things that are coming down the pipe, and some things that hopefully the SEMA membership will be able to get behind and start to work towards and build products for, and that may be the next thing that's coming down the line that will work with the products that these guys here have been talking about. So when I say connected vehicles, I'm not necessarily talking connected vehicles using cell phone and doing some of the telematics type things. I'm talking connected vehicles using dedicated short-range communication at about a 300-meter radius that may be coming down the line for a mandate from NHTSA, and I'll talk a little bit about that as we move forward. So the idea of the connected vehicle program is we've got drivers and operators, we've got vehicles and fleets, we have wireless devices, and we have infrastructure. How do we make all four of those work together as seamlessly as possible as a short-term enabler for reducing crashes and improving mobility, and a longer-term enabler for providing some autonomous vehicles or self-driving cars? So the concept is, how do we make all these pieces and components work together? And I'm going to apologize up front. This is like an 8-hour presentation that I've got. I've tried to pare it back to about 7 minutes. So I'm going to skip over a lot of detail. Please feel free to ask questions or come up later, and I can work with you in the future on that. So US DOT with the FCC in about 1999 set aside spectrum at the 5.9 gigahertz bandwidth for connected vehicles for improving driver safety. The concept is I can have vehicles that talk to one another. Those vehicles can avoid crashing into one another is the ultimate objective. If the vehicle can talk to the traffic signal, the vehicle may not run the traffic signal. So it's a way to enable safety within the vehicle and moving forward with that concept. Some real basic information up there that messages transmitted 10 times a second, very low latency, 300-meter radius on the 5.9 gigahertz. So there's a lot of components of that have been worked on over the past couple of years, but also working with cellular, with 4G, with satellite and fiber optic. How do we bring all these communication components together to improve safety and mobility? So what we've come up with that working within this side of the industry is this path to deployment, which goes back 2011 on this slide, but actually probably goes back to 2000 or the 1990s with some of the earlier discussions. But the key things to look at on this, by the end of 2013, so sometime within the next 6 weeks, NHTSA will be making a decision on whether or not to enter into the rulemaking process to mandate this into every vehicle. That's important to understand. If they enter into this rulemaking process within the next probably 5 years, the concept is that this will be mandatory technology in every new vehicle coming off the lot, which is great for new vehicles coming off the lot and those people who are buying cars in 2020. But those that have cars that are 2019, 2018, 2015 cars are going to probably want to put some of these concepts, these technologies in their own vehicles. And that opens up some new opportunities for the SEMA members and for all of you to be able to start to work and think about this for how you can develop products to integrate into that future. And this goes into some of the other deployment curve pieces of it. Over the next couple of years, and this is the next section of this presentation, there's a number of test beds and facilities and resources that are available to all of you to work with in order to learn for education, for testing and demonstration purposes, because the concept of building out an entire system is unwieldy at best, impossible for the most part for most of the people in this room. But because US DOT is backing this with a lot of funding, we have roadside infrastructure, we have some basic and vehicle radios, we have roadside radios, we have some networking components that you can use to work through to support development. One of those pieces that's being built over the next year is this vehicle to infrastructure reference implementation for what the roadside piece might look like for this connected vehicle world at the 5.9 gigahertz side. So this is being built over the next probably 12 months, but pieces of it are available today. Of course, this opens up a lot of challenges. If I have the vehicles if my vehicle's talking to your vehicle, is talking to a traffic signal, I have to make sure that I have security, that I have trust between those messages and enable that trust, that the messages are valid, that the message coming from my car to your car is a valid message. If you're going to make safety driving decisions or stopping decisions based on a message from my vehicle, you want to make sure that your car trusts that message. So we've got to work on security for that, as well as defense against attacks. And one of the things that's new in this whole space of connected vehicles, and this is the broad thing, is you now have a pipe into a car. whether it's through cellular, whether it's through cellular from a cell phone into an application in the dashboard, or whether it's through this 5.9 gigahertz bandwidth directly into the car. With the 20 million plus lines of code in a vehicle, that's a way that could be hacked in by hackers into a vehicle to take over control of a vehicle. So that's another area that we need to look at security, that we're going to need really smart people and good people to work on. How do we make the car hack-proof with these new technologies? A lot of legal and policy issues, and my friend Paul will talk a little bit about some of these as he comes up, but you've got, does the US DOT have authority, and how much authority to mandate this? How do we deal with original purchases versus aftermarket into an older vehicle? How does the aftermarket making a modification to a new vehicle with this technology, how does that change the way the vehicle operates or the system operates? A lot of these questions have to be worked on and defined and decided over the next few years, and that's where we're going to be looking to the industry as a whole to provide input and support to help ensure that what we do with this connected vehicle concept doesn't change the way you guys work and change the way you operate, that we can all work together. We're looking at a number of mobility applications. Obviously, INRIX has been, I've seen their logo up there a few times. Waze, Google, and others are some of the mobility side. But there's a whole host of new mobility applications that can be created from just this short-term connectivity between vehicles, or short radius connectivity between vehicles and between the roadside. US DOT is working on prototype applications and doing some prototype research for this, with the intent being to finish this research and give it to industry. To let industry, let the smart minds, let the marketing side take over these applications, build them, commercialize them, but let US DOT take on some of the early riskier development component of it in terms of the initial dollars that are spent on some of the research phases. So that information is all available and is actually all open and looking for people that want to step in and take over different parts of the program. Mentioned there's test beds across the country, from Northern California in Palo Alto to Anthem in Phoenix, in the Phoenix area, Orlando, Florida, a number of them in the Detroit area, Detroit, Ann Arbor, and the Novi area, Minnesota, New York, and Northern Virginia. They're coming together as coordinating what's happening in these test facilities to enable and ensure that you're able to come in and test and develop and do research and develop new products and have the ability to test things in different areas with the same standards and the same technology on the back end so that we can all work together and help you to be able to move your product forward. A number of testbed resources, not going into a whole lot of detail. These slides are available later, and I can obviously ask questions or answer questions after the session. But a lot of resources are available today at no charge to you if you want to use them to help develop, if you want to use them to help test technologies in this field. Within Southeast Michigan, and this is a nice eye chart for you on a Thursday at the end of SEMA show, building an architecture to enable data to be pulled off of vehicles and used for some of these safety and some of these mobility applications. This is a prototype architecture. It allows for security, it allows some trust between the communication components, but it's built to help to learn how some of this stuff works. And it's being built to help you develop applications as well, whether it's in vehicle, whether it's in the back end with data, or whether it's anywhere in between the overall system. The data exchange process, again, just a real brief overview, but we've got the vehicle, you've got a roadside device, and you have back-end servers, whether they're a near-end server that may be a DOT-supported and operated server, or a pass-through of your packets of information all the way through to your own servers. So how do we set up the encryption? How do we set up the signature authority to make sure that these packets of data go where they need to go, and that trust and privacy is ensured as we continue to develop throughout the program? In closing, just a couple of brief thoughts. We're awaiting the NHTSA decision. Next 6 weeks, NHTSA will make a decision on where they're going to go with passenger cars with a mandate. 2014, commercial vehicles and trucks, there will be a similar decision. And if you know NHTSA, they have more authority and more ability to make rules with trucks than they do with passenger cars. So they can enable things faster with trucks. A lot of testing and a lot of development needs that have to happen. And we're looking to expand and add deployments to increase the depth of understanding. And just in closing, I look at this and working through some of the development and some of the research sides of things, there's really 5 areas that we're looking at for research, and I think 5 areas of great opportunities for development. There's the roadside devices. How do you build roadside devices and manage and maintain those in application certification? The in-vehicle devices. I have an in-vehicle device, I have the radios, I have the applications, I have the integration with what a lot of these guys are doing here. We need people that are going to step up and build applications and build those programs and work within that. But I think there's great opportunity within there for long-term growth. There's the whole security system. How do we build the security system? How do we operate and manage and maintain this overall security system to ensure trust and ensure that the system works and can't be hacked? How do we deal with mapping? If I've got autonomous vehicles or automated vehicles and I'm relying on mapping, how do I ensure the map stays accurate? How do I ensure that mapping data is accurately transmitted so when there's a change, that change happens at all the databases that are responsible for coordinating these systems? And last but not least, there's the back end. How do I manage the data? How do I manage applications on the back end so that the entire system can work and that your application can provide the information, the data, the resources back to your customers? So it's really a lot of great opportunities that are coming up in the future with the whole connected vehicle concept at Five9. It's, to be honest, a very exciting time, and I continue to look forward to working with SEMA and working with all of you in this room. So this was drinking from a fire hose on some of these technologies. More than happy afterwards to answer questions and point you to different resources. Thank you.
Thank you, Greg. Thank you, Greg. That was excellent.